Thank you very much. I'm honored to be able to talk to you today, and I'm sorry that I can't be there in person. And I hope that I can come visit again sometime soon. So today, I want to talk about the rhythms of the sun, and related to that, I want to talk about some of the more profound impacts that the sun can have on our daily lives that many are perhaps not aware of. So I'll start talking about some of the rhythms and cycles that the sun has with other celestial bodies that we see, but then move towards what is one of the more fundamental rhythms within the sun that is unique to itself and other stars like it. So, the sun is, I would say, in many ways, something that we often take for granted. It's been part of everyone's life for millennia, and as many had say, we can always sort of rely that it's going to rise every day and set every day. And oftentimes, probably the most interesting time we see the sun is maybe at a sunrise or a sunset when we can see the beautiful interaction of the light with clouds in the atmosphere. And most of the time, it's something that's sits in the sky. We can feel it, but it's too bright to look at. And without the right kind of protective eyewear, it's something that we can't see comfortably with our own eyes. But there are times that we can, in fact, see a unique view of the sun that is quite a rare, spectacular event. Um, but first, we think about the rhythms that we're used to, and probably in addition to just the rise and setting of the sun, the rhythms that we're probably most familiar with are the seasons. This is the interaction of the sun and the earth as the earth orbits around it. And the earth has its own natural tilt. And depending on where it is in its orbit, different hemispheres are either facing towards the sun or facing away from the sun. And of course, that's giving us the seasons, giving us summer when it's pointing closest and giving us winter when it's pointed away from it. But another type of pattern and cycle that many have an opportunity to see is actually when we have a dance between the sun and the moon. If the alignment is just right, the moon will move in front of the sun, and given the amazing fact that the sun is 400 times bigger than the moon, but it's 400 times farther away. And so that alignment is just perfect at times that the moon completely blocks out that intensely bright solar disk and allows us to see this incredibly faint, ethereal outer structure of the sun called the corona. And it's seemingly a relatively rare event, but in fact, these happen, um, these total solar eclipses, as we call them, if you're in this special little path where the shadow of the moon runs across the sun at many thousands of kilometers an hour, you experience this, and it's actually only rare because of where you are on the earth. And in fact, they happen all over the earth. And you can see all of these different paths that are happening over the 21st century. And even this appears to be somewhat random, but in fact, many of these lines form sets that happen over cycles of roughly 18 years called a Soros cycle, something that was discovered thousands of years ago. And this is another example of this intricate motion between the planets, between the bodies in the solar system and the sun that we can see manifested in many different ways. And another example of something that we see in terms of a pattern is when we start to see a pattern that is unique to the sun itself, that's independent of the other planets, of the other bodies, and that is sunspots. So most famously, the one of the first to notice these and actually look at these safely with a telescope was Galileo. And the sun has a pattern, has a cycle when it goes from very few sunspots, these little dark patches, to a lot of sunspots. And this pattern, this cycle going from few sunspots to many sunspots back down to few sunspots takes roughly 11 years. We call this a solar cycle. So when there are few sunspots, we call this solar minimum. When there are a lot of sunspots, we call this solar maximum. And observers and scientists have been monitoring this for hundreds of years. And the most reliable records actually started in the roughly the 1760s, and from that point on, we have numbered these cycles, these solar cycles. And currently, we've left cycle 24, and we've entered cycle 25. But even looking at these, we can see that some are slightly bigger, some are slightly smaller. And if you zoom in, you can actually see that some are slightly fatter, some are slightly thinner. So it's not exactly 11 years. Some are a little bit longer than 11 years. Some are a little bit shorter. And even looking at the cycles individually, there's even two little humps on some of them. And in fact, what's happening here is we're seeing a slightly different cycle from the northern part of the sun, the northern hemisphere, and the southern hemisphere. They each actually have their own cycle, together creating the whole solar cycle. But one of the things that we've discovered is we've had a very limited view of this because we've been viewing it from the ground, viewing it through the thick atmosphere of the Earth. And while that's been wonderful for us because it protects us from many of the harsher wavelengths of light, things like X-rays and ultraviolet and gamma rays, it also has not allowed us to see this different, unique perspective of the sun. And so what we did is we started putting telescopes into space up high above the atmosphere, allowing us to see these wavelengths of light that we could never see before. Most notably, recently in 2010, we launched what's called the Solar Dynamics Observatory, giving us a view of the sun in 10 different wavelengths, from the visible we're familiar with all the way up to nearly X-rays. And each one of those wavelengths that we're able to now give simultaneously at an amazing pace of approximately every 12 seconds, each one of these shows us a completely different view of the sun. So where we saw at one time these dark spots in some wavelengths, we see these bright patches. We see all kinds of structures on the edge of the sun. And we've learned that as we move from more energetic light, from ultraviolet to what we call extreme ultraviolet to X-ray, it's showing us actually higher and higher layers of the sun. So we're starting with the visible light that we're familiar with, we're seeing very low down in the solar atmosphere. And as we move up into more energetic light, we're actually seeing higher and higher up. And in fact, we begin to see the layer of the sun that we can see during a total solar eclipse, the corona. But in addition to seeing those different layers, we found that the temperature itself of the sun actually increases as you move away from the surface and get higher and higher, going from 10,000 Celsius up to several million Celsius. So counterintuitive. We're used to the idea that if I'm standing next to a bonfire or a campfire and I feel the warmth, as I walk away from it, the temperature goes down. And that's something that we're used to from thermodynamics, tells us that the temperature always goes from high to low. So something is happening in the solar atmosphere that's actually making it many thousands of times hotter farther away than the surface. So counterintuitive, completely baffling to scientists hundreds of years ago. But what we have now discovered is that there is a unique energy source within the sun that is allowing energy to move higher and higher in the atmosphere and power this amazing structure we call the corona. And if we look at now the sun over time in these extreme ultraviolet light, not the visible light anymore, you can see that it's not just a simple solar disk with these dark patches, but in fact, during solar maximum, where those dark patches are over top of them, we have these bright areas with all kinds of activity, all kinds of dynamics that's going on. And in fact, we see all of these little loops and structures, and those loops are, turns out to be magnetic fields. Now, magnetic fields that we're used to are invisible. We can feel them. If we put two magnets together, we can feel the force, but we can't actually see the magnetic field. But the sun's atmosphere is itself magnetic and electric in nature, something we call a plasma. And that plasma highlights these magnetic fields and makes them go from invisible to visible, giving us tracers of what's happening. And we can look again at many different wavelengths, and you see all these dynamics, huge explosions, billions of tons of material rushing away from the sun at millions of kilometers an hour. This is giving us the perspective of this unique dynamic corona that we've never been able to see from the ground. Here's a zoom in on one of the wavelengths. You see those loops. Those loops, turns out, are actually connecting the sunspots. The sunspots themselves are almost like magnets, and these loops are connecting different sunspots to each other. And what happens over time as these magnetic fields get twisted, much like a rubber band or a string, and if you twist it and twist it enough, eventually they must pop. They must release that energy. And that's what's happening on the sun. So if we can look at this real quick schematic, during solar minimum, the magnetic fields run through the sun north-south. But because the sun itself is not a solid body, its material holds on to that magnetic field and twists that magnetic field around until it starts to pop out the surface. And that's where we get the sunspots. And if we look at another diagram, you can see the magnetic fields coming out where the sunspots are, and they're dark. These magnetic fields rise up from underneath the surface, and where they hit the surface, they suppress the heat, making it appear that they're darker compared to the area around them. And then when those magnetic fields get twisted enough and release their energy, we have these massive explosions releasing light and matter into space. So we can look at a time period, actually a very famous one. As a matter of fact, I was at a meeting in Brussels during this time. It's called the Halloween storms, because it happened in 2003 at the end of October, beginning of November. These massive sunspots appeared on the sun, many, many times the size of Earth. In fact, some of them closer to the size of the planet Jupiter. And those sunspots contained massive amounts of energy. And as they became more and more complex, more and more twisted, they began to release that energy in the form of solar flares and blasts of material we call coronal mass ejections. And here you can see, looking at this extreme wavelength, this extreme ultraviolet wavelength, you see all of these little pops and flashes, which are all, each one of them, solar flares. And we see material moving around that's spit out into space. And in matter of fact, if we move to what we call a coronagraph, where we actually block out the sun. So we've overlaid the sun on it, but in fact, the sun's blocked out. And so the bright disk is no longer there. And you can see all of this material coming out, these puffs of smoke, which are these billions of tons of solar material. And then right there, you see all of that snow are in fact super high energy particles that are accelerated by these blasts, by the shock waves that are hitting the camera. And these are some of the things that we're most interested in, because all of that impacts our technology. It can impact our satellites, disrupt our communication. And those particles you see hitting the camera, in fact, interact with the human body, which makes it completely dangerous for an astronaut traveling to the moon or eventually to Mars and experiencing these solar explosions. There is one aspect of it that is in fact beautiful, and one of the first ways that we've seen these solar eruptions for many, many thousands of years, and that's the aurora. The northern and southern lights are in fact that material interacting with the upper atmosphere, interacting with oxygen, giving us the greens, interacting with nitrogen, giving us the blues, and then the oxygen also gives us these reds. And these dynamic structures are happening overhead. But all of that impact, for example, from the 2003 Halloween storms, had a profound impact across the globe. We had power failures in Sweden, for example, severe blackouts of radio waves that impacted commercial airlines. More than 20 satellites were impacted in a Japanese spacecraft. Science spacecraft was lost. We have no idea how many spacecraft were impacted that are military spacecraft, because of course they don't tell us about what happens with those. And even the impact was so strong that, ironically, the radiation detectors on the Mars Odyssey spacecraft lander sitting on Mars was knocked out, and we saw parts of the Martian atmosphere blasted into space and lost forever. So it can have a profound impact on us, and something that is an ongoing cycle that we typically most don't relate to. We don't see it. Maybe we see the beauty of the northern and southern lights, but this is something that's impacting our technological society as we become more and more sophisticated and have more and more advanced technology. We become more susceptible to what the sun has to throw at us. And one additional thing is, there's another cycle that the sun has that we can't even see very easily from where we are. The sun is also constantly sending out material, this steady flow called the solar wind that fills the solar system. And if we were to step back from the solar system and look at it, we would actually see this material create this huge bubble, and that bubble will ebb and flow back and forth as the sun becomes more active and less active. The solar material makes that bubble around the solar system, in fact, breathe in and out. So currently, we're actually getting close to the next solar maximum. So we are coming into a period where solar activity is going to reach its maximum, where originally, this is a slightly older plot. Originally, we expected that this was going to happen at 2025, but what we've seen is that the predictions have far been surpassed by what the sun has been doing, and we probably will start to see this solar max period in 2024. So it's going to be a very exciting time. We'll have in the US, for example, from Mexico, US to Canada, another total solar eclipse, which will be happening around the time of solar maximum. Currently, NASA and ESA have two complementary missions, the Parker Solar Probe, which is flying through the sun's atmosphere and will reach its closest approach in 2024, and the amazing Solar Orbiter mission from ESA, which is now moving out of the solar system itself, above the plane of the solar system, looking at the poles of the sun to give us a perspective that we've never had before, because we actually can't see the poles very well because we're all sitting in the plane of the solar system.
Alex,
So
your time is up. So if you want to
okay.
wrap up in 1 minute.
Yeah, so it's an exciting time, and I encourage everyone to keep an eye on the sun, to see what's happening in space. We will start to see what the impacts will be here on Earth. And it's going to be an exciting and interesting time for science and for society. So I'll stop there and answer any questions.